Okay, hello folks. Welcome to another week of offsite learning. This week we're just going to keep going through our geology unit. Okay, so we are still in this notebooklet here. We are starting off on page 35 this week. Okay, so this week's all about glaciation and how the Earth's climate has changed over the years. Folks, I'm also just going to say this up top. I usually say it at the end, but just in case you're clicking out before the video ends or anything, okay, which I get. Just a quick reminder, okay, if you're struggling with stuff, if you have questions, that's okay. You should have questions, right? So just make sure you're popping into Flex, sending me an email, filling out that document where you can ask questions, or even calling me on the phone, okay? I know offsite learning can be tough. There's challenges, okay? But we have to make the best of it. So don't feel like you have to do this alone, okay? Reach out if you're needing help with any of the material, okay? Or you just want to talk even. Okay, so before we really jump in, let's look at the big ideas for today, okay? So be on the lookout for these as we go. First one, what is a glacier? Why isn't all ice considered part of a glacier? What is glaciation? What are each of the following features and how are they formed by glaciers? So we're going to look at till, eskers, moraines, erratics, U-valleys, kettle lakes, and drumlins, okay? Sounds like a lot, but they all kind of are formed in similar-ish ways. All right, so like I said at the top, this week is all about Earth's changing climate over its history, okay? It's hard to talk about how Earth's climate has changed without looking at the idea of glaciation and therefore glaciers themselves. So that's what today is going to mainly be about. What are those things? How have they shaped the Earth's surface? Which also ties into the changing Earth, right? Glaciers have changed the Earth, which is what this unit is all about. So first things first, what is a glacier? It's a permanent mass of ice on land, okay? That permanent part is what makes a glacier a glacier. So here in Fort McMurray, we get lots of snow, right? Lots of ice in the winter. Why is our ice not considered part of a glacier? Well, because the summer comes and it melts, right? It's not going to be there year round. So that permanent part is really important. So if it doesn't completely melt in the summer, right, then every time it snows again in the winter, that glacier can build up and build up, and they can get pretty massive, okay? The other key point of a glacier is that it's actually always moving under its own weight. So ice doesn't really flow, but if there's enough pressure, if it's heavy enough on top, it actually can start to kind of flow, right? You and me usually think of ice, we don't think of it as flowing, but if you get enough like a heavy glacier, you can actually see it start to flow. I'll show you in a sec what I mean. All right, and then our next definition here is just an ice sheet. What's an ice sheet? It's just a very large, and when I say very large, I mean huge, like tens of thousands of kilometers wide, okay, glacier. An ice sheet is massive. We really don't have those anywhere except at the poles, so at the North Pole or at the South Pole, okay? And like we said, when it gets heavy enough, it flows, and as it flows, it erodes the landscape. Now, what is glaciation? Well, it's just the formation and movement of glaciers. So it's when you have glaciers that are forming, moving, whether they're going out, in, whatever, however they're moving, that process is part of glaciation. So now with this in mind really quick, that glaciers are permanent masses of ice, where do you think we might get them? Or where have you maybe heard of glaciers being? So we already kind of said, right, at the poles, because it doesn't get hot enough there in the summer for them to melt, right? So they are there all year round. Anywhere else you could think of you've heard glaciers? Well, you may have heard of them in the mountains, right? And in the mountains up high, as you go higher in our atmosphere, it gets cooler, right? At the tops of the mountains, even in the summertime, the tops of high mountains are snowy, right? You've probably seen that if you've driven through them. So even in the summertime, they might not melt, and that allows there to be glaciers up there because they're not melting in the summer. Snow is building up and building up every year into packed ice that flows under its own weight. Okay, watch a quick video here looking at how glaciers flow.
Although glacial ices are solid, it actually flows like a river. It's incredible to think that this much ice is constantly on the move. I've been climbing up to see what drives the glacier. And it's the phenomenal weight of this enormous ice pack, over 9 kilometres long and up to 500 metres deep. Millions of tons of ice crammed into this valley. Built up from layer upon layer of snow, this monumental river of ice is constantly being topped up by fresh snowfall, and that keeps it flowing downhill. It makes very slow progress, but there is a way to see it move. A time-lapse camera shows that Nigod's surface ice travels at around 275 meters per year, carving away the rock as it goes.
And now we're just going to take a look at some of the ways that glaciers over the Earth's history have changed how the Earth looks. They've actually changed it a lot, okay? So we're going to look at some glacial landforms. After you've seen these, you might realize, hey, I've seen those before. I didn't know a glacier made them. Or maybe you did, but either way, after today, you will. So the first thing we're going to look at is till. Till is basically dust, sand, whatever, fine sediments made by a glacier. How does it make it? Well, these are huge, heavy ice sheets, and as they move, they scrape and they grind up the ground below, right? And so if you take a rock and you scrape it and grind it and grind it and smash it and grind it and smash it, you'll eventually get basically sand, right? Sediments, we would call those. So till is just a collection of rock, sand, and clay torn up by the glacier from the ground underneath it. Then when glaciers eventually retreat, when the earth gets warmer, or when maybe it's just summer and they're not going to completely melt, but they might go backwards a bit, okay, they can deposit this till over the landscape. So anyone recognize this picture here? This is actually the Athabasca sand dune. So this is just like a couple hours north from us, right? And when you're in the middle of it, this literally looks like a desert. There's pictures of it. It's really cool. It looks like the Sahara Desert, okay? But what it is, that sand, you can probably guess, doesn't belong there, right? There's not too many sandy, deserty looking places in northern Alberta. However, how did it get there? Well, a long time ago, there were glaciers that extended very far south from the north. It could get that cold, okay? There were periods in the Earth's history where the climate was different enough to allow that to happen. And as they melted, right, as they retreated back up north and they went past where Fort McMurray is now, they dropped off a lot of that till, that sand and clay that they had picked up after grinding the earth. The next kind of landform we're going to look at are eskers. So eskers are actually made of till. A lot of these land features are made of till, but it's a little more specific than just dropping off the till into a sand dune. So an esker, you can see them here, right? They're long snake-like hills, okay? Long, winding snake-like hills that are formed by piles of till. Again, left behind by ancient glaciers. So you can imagine a glacier pushed its way through here some long time ago, okay? And then eventually what happened is it melted, right? Obviously, there's no glaciers forming at this place now because you can see it looks nice and sunny and green, right? Not cold enough wherever this place is to have glaciers, permanent ice and snow. But when those glaciers retreated, they left behind a lot of till, kind of into these shapes of these eskers, these long, winding, snaky hills. The next one is a moraine. How is a moraine formed? Well, again, this is actually a glacier. This is a alpine glacier, which just means it's in the mountains. So in the winter, what do you think a glacier does? Do you think in the winter a glacier is going to grow or shrink? Well, it's cold, it's snowing a lot, so it's probably going to grow, right? And then the summer, it's going to kind of shrink. So what you have happening is it grows down to here, right? And then the summer comes and it melts back up a little bit, but then winter comes again and it grows down to there again. And then, of course, summer comes and it melts a bit and it retreats. So over time, what you kind of have is this push and back and push and back and push and back of a glacier retreating and advancing and retreating and advancing, okay? What that starts to do is it kind of starts to, what that starts to do, kind of like you just pushing into the dirt with your shoe, right? It starts to build this little ridge, and you can even see that water in there? Guess where that probably came from? Yeah, it's probably melted glacier, okay? So that would probably be very cold water. In fact, if you've ever gone swimming in Jasper or Banff, most of those lakes are freezing because they're all made of melted glaciers, okay? So that is all a moraine is. It's a ridge of glacial till pushed up by an advancing glacier. Okay, glacial erratic. Erratic, what does that word mean? Have you heard that before? It kind of means unpredictable. It's not how it should be. Okay, that's kind of what we're talking about here. We're talking about a boulder that really shouldn't be where it is. If you've ever been in a field and seen a big boulder and thought, how'd that boulder get there? Okay, there's a good chance it was a boulder carried and then dropped by an ice sheet during the last ice age. These are all over Alberta. Okay, you can see these all over. Next time you're driving past a farmer's field or something, keep an eye out for these. You'll probably see a couple, unless the farmers had them removed, of course. Okay, next one. A good way that you can kind of look at the difference between how water erodes the land and how water changes the landscape and how a glacier can do it is by looking at the shape of the valleys. Okay, so yes, water erodes the land, but water is kind of, well, it's more gentle, right? It kind of slowly just chips away and chips away and chips away so that at the end it just kind of keeps building this valley deeper and deeper, but never really scraping it out or anything, right? Just kind of whittling away at the middle of it, making the middle deeper and deeper and deeper. Whereas glaciers are, they've got a lot of mass, right? They're pretty serious. So they kind of just can bulldoze right through a valley and carve it out pretty intensely, right? Yes, it still takes many thousands of years, but compared to a river, it can really just kind of crunch out this valley, okay? So bulldoze large valleys as they move. You can see the diagrams here. You can kind of see it, right? We say that rivers carve V-shaped valleys. Why are they V-shaped? Well, what shape is that? That's a V, right? Whereas mountain glaciers leave U-shaped valleys. Again, why? You guessed it. Looks like a big U, right? So a V versus a U. There's a diagram. You want to see it in real life, right? That's the difference between a valley carved by a river, very V-shaped, right? Very V-shaped, versus carved by a glacier where it just went and kind of completely cleared it out, scraped it out with its huge mass of ice and snow. Okay, now kettle lakes. These are kind of cool because the glacier not only makes the hole, so first the glacier scraping over the Earth's surface, it makes a hole, so it fills a depression made by an ice sheet, right? It scrapes it up, and then it actually fills in the hole. When it starts to melt, it fills it in with its own water. So first the glacier makes the hole, and then the glacier fills up the hole with its own water. What happens when we get that is little small round lakes, okay? So glacial ice melts, fills up a hole that it made, and then you have what's called a kettle lake. Okay, so these are some pictures of kettle lakes, these kind of round, small-ish usually, although not always. In fact, the biggest lakes on Earth, the Great Lakes, those are lakes left behind by glaciers, a huge glacier that we'll talk about a little bit later. Okay, by the way, just in this diagram here, you see these would be kettle lakes, right? The glacier at one point grew enough to carve out this valley, and then of course it melted at some point because it's not there anymore, but that is a kettle lake. So that is a kettle lake left behind by when that glacier melted. Okay, and the last land feature we're going to talk about is a drumlin. Now, these are awesome. Drumlins are really useful because they can actually tell us more than just that, hey, there were some glaciers there, right? All those other ones we were looking at, well, they were cool. They told us, okay, yep, there were glaciers. Cool, right? This one can actually tell us which way the glaciers went, which way they advanced, and which way they retreated. So it's a teardrop-shaped hill, okay? And it's formed sort of when debris, chunks of rock and stuff that have gotten picked up by the glacier, they kind of get caught on something and start to build up, or they kind of build their roots. I'll show you what I mean here with this video. So we'll watch a drumlin form. Okay, and so you can see from that video that the shape of the drumlin will point in the direction that the ice sheet advanced, right? Advanced means grew, right? So by looking at these drumlins, we can actually start to see, okay, looking at this one, right? You can tell the glacier must have gone that way. And then, yes, eventually melted. But when it was growing, it grew that way as it carried debris and it kind of built up and got caught, right? Here, see these? This glacier, we might have a landscape like this and we say, well, it looks like there's definitely a lot of land here that was formed by glaciation, but we don't really know how it came in. And then you go, aha, look at these drumlins. Looks like the glacier must have advanced that way, right? And then, of course, melted the other way, leaving behind some neat features. Okay, there's a picture of a real drumlin. Again, these drumlins, you can find them quite a bit in Alberta. Most of these features you can find all over Alberta because, as we're going to talk about a bit, a lot of glaciation has happened to Alberta over the past few million years. Okay, in fact, all over the world, there's been quite a bit of glaciation, but we are definitely part of that. Okay, so that actually wraps up topic one. I'll just throw these back up so you can kind of review in your mind, answer these as you go. Okay, what is a glacier? What's the actual definition? Why isn't all ice considered a glacier, right? So that goes back to that one, right? What makes a glacier different than the ice we get in Fort McMurray? Okay, what is glaciation? What does that mean? What are each of these features? Okay, and how are they formed slash left behind by glaciers? So if you want some practice with this stuff, okay, try the topic 1 section of the practice assignment for this week. You can find that in the Google Classroom and in the agenda.